It's been determined that a need exists for a simple system to quantify the embodied carbon in concrete. Concrete's the most used building material, and it's also a contributor to greenhouse gases, principally through the Portland cement component of it. And there are many sophisticated ways to assess the embodied carbon in concrete, but they aren't applied to about over 90% of the concrete that's poured in the world because they're very expensive, time-consuming, and the concrete actually gets used by a specific mix design for every batch of concrete almost. So doing an expensive long study to understand the embodied carbon just doesn't fit in. There's been a new standard created, funded by the Canadian government, and developed over a year by a list of experts called the CarbonStar standard. CarbonStar allows someone to take a simple mix design and quantify it. Now, when we look at concrete, it consists of water, aggregates, and sand, and it has the capability to hold quite a bit of CO2 or produce CO2. So if we look at an average yard of concrete, we can see how a CarbonStar calculation is put together. For example, there's the emitted carbon and the net sequestered carbon. Typical concrete has cement, sand, SCMs, admixture, water that are all CO2 producers, and can have, with the modern concrete, sequestering components such as injected CO2 or calcium carbonate limestone aggregate that is made out of CO2. This system can be applied to standard cement. For example, typical cubic yard of concrete may have 600 pounds of CO2 represented in its production or so. And when we add up all the producers of CO2, it comes up with a CarbonStar rating of over 600. There are other examples in the future. The way we're going to handle the carbon footprint of Portland cement is principally through capturing the CO2 post-combustion at the kiln. So if we capture half of the CO2 coming out of the kiln, we can lower the carbon footprint of the yard of concrete and end up with a CarbonStar rating of about 300. Or for example, by using SCMs, a very popular method today, we can replace up to, say, half the Portland cement with SCMs. And this is another way to cut the carbon footprint of the concrete in half. Injecting liquid purified CO2 has become popular. Here, the liquefied CO2 is injected, and about a pound of it is sequestered in a yard of concrete, lowering the CarbonStar rating by about a pound. Or now that mineralized aggregates are available with sequestered CO2, here's a case where the fine aggregate, the 1,200 pound, the 1,500 pounds or so of fine aggregate are included. They have a carbon footprint of negative 600, and they bring the concrete down to close to zero for CarbonStar. And we can look at many different examples where we put all these methods together and get down to a negative 270 CarbonStar rating. This standard was put together over a year by a panel of experts, far-reaching from the concrete manufacturers to many other constituencies. You know, the MIT Concrete Sustainability Initiative, the Stanford Carbon Storage Initiative. And so there's quite a bit of feedback and input into the standard. This standard has now been adopted and is getting used in many places. For example, here we're looking at the San Francisco International Airport Sustainability Guidelines, and They cover many aspects of the sustainability and circular economy of the airport. And when it comes to looking at the concrete, it requires a CarbonStar rating of 200 pounds per cubic yard. Now, remember, a typical yard is more like 600 pounds. This is requiring it be cut by about 2/3. Or if you go on and you look at their stretch goals, here they have a CarbonStar rating of 0, and they're hoping to attain a rating of negative 200 pounds per yard. So what CarbonStar does is it allows simply an average ready-mix plant, which is where most of the carbon is coming from, to quantify the embodied CO2 in their carbon, in their concrete, and meet a specification like at the San Francisco airport with a low carbon, or in that case, negative carbon concrete. Thank you very much. That concludes my reporting.